to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technology. Joining me to answer this question is Stephen Lacy with Belden, a supplier of industrial automation cables, connectors, networking, and cybersecurity technologies. So, with all of those reasons and types of failures that are common that we've been discussing here so far, there's still the fact that many manufacturers still rely on reactive maintenance rather than being more proactive. So, based on your experience working with end users in industry, can you talk about what the typical cost factors are that are associated with this more generally used reactive approach?
hmm Repair or replacement of the failed component obviously is the first thing, but that's assuming it can be quickly sourced and shipped, and we all know that can be quite challenging nowadays. There's maintenance labor to disassemble, repair, and then reassemble the equipment, and depending on where the failed component is, within the machine or the plant area, that may require working at height, which has an associated risk. There's makeup production labor, which may be required during overtime hours. Unplanned maintenance can also have a safety component, again, depending on the hazards involved. Random failures puts a facility into an off-normal operational state that the upstream and downstream equipment and the operations team may not be prepared for. So you definitely you would like to avoid that if when you can. Equipment failures can greatly lower the production KPIs of a plant or a facility. And unreliable production equipment can create an atmosphere of uncertainty over whether production goals can be met. So the goal here is to really ensure that the production environment is set up and is robust enough so meeting production goals can be solely based on personnel performance and not on machine or equipment issues. So you definitely like to get rid of those. Finally, production delays are always a concern, since they could make your customer try a competitor's product, and that's an area you'd like to stay away from.
For all the obvious reasons there, absolutely, yeah. So, right now, we're talking about reactive versus proactive maintenance, but, across industry right now, there's a lot of interest in predictive maintenance to allow for even greater levels of proactive maintenance. But is it possible without specialized predictive maintenance software to predict when equipment's going to fail?
It is, yes. That's a condition statement, but it's getting better and easier all the time. We start by first identifying all the production critical components and equipment in the automation, networking, sensors, and electrical component realm. If the facility or the plant does not have drawings or accurate drawings, then sketches are fine, possibly with photos. Once you know what you have, the next step is start by installing inexpensive wireless sensors. Those are nice because they operate outside of your current, IT and OT networks, which are production critical. The sensors available nowadays can measure position, current, motion, distance, pressure, velocity, you name it. So there's an inexpensive sensor to identify most excuse me most any critical parameter. Next is replace failed power supplies with smart monitored supplies. There's some units out with IO-Link that's built in, and some of the parameters that are included in that link is actually the remaining useful life of the supply, which plays to the predictive analytics nature of the exercise. Install network monitoring software to detect when a network switch may be starting to fail or has failed, You'll see spikes in network traffic that don't align to anything else, and those may be indicative of an impending failure. And you can install wireless motor vibration and temperature sensors on motors with an analytics software package. And I would just note that the solution ideas described can operate either on the existing facility networks, or they can be on a separate, smaller network dedicated just to the equipment monitoring and analytics.